Hey everyone, welcome back to my channel. If you are new to this channel, hello, my name is Shagun and you are watching Learn with Shagun. So here I'm gonna start a new series on my channel which would be particularly regarding grade 12th naming reactions which are included in organic chemistry, and these reactions along with mechanisms I would be explaining, which would be helpful for graduation students as well, as they look for mechanisms a lot. In this video we are gonna study Wurtz reaction. Okay, so Wurtz reaction basically is a coupling reaction for alkane preparation. So the purpose of this reaction is to obtain alkanes. We are gonna get symmetrical alkanes as a result of this reaction. Okay, so what is the general equation of the reaction? Alkyl halide combines with metallic sodium. Okay, in the presence of diether they give you symmetrical alkane along with the sodium halide. Whatsoever halide you have used, you are gonna get sodium salt of that. इक्वल क्वांटिटीज़ में हम दोनों को लेंगे एंड एज अ रिज़ल्ट क्या होगा, सोडियम अपना सॉल्ट बनाकर हेलाइड के साथ निकल लेगा और जो आपका दिस एल्काइल चेन जो है, द टू एल्काइल जो एंटिटीज़ होंगी दे विल इवेंचुअली गेट कनेक्टेड टू ईच अदर एंड दे विल रिजल्ट इन द फॉर्मेशन ऑफ अ सिमेट्रिकल एल्केन, एंड ऑल ऑफ दिस इज गोना हैपन इन द प्रेजेंस ऑफ ड्राई ईथर. ओके, so let me tell you something. There is a purpose of taking everything which we have taken over here. So let us look into that why this specific kind of thing is only used in this reaction. So if we talk about sodium, so sodium is being used because it's a good source of electrons because it ionizes, right? Now if we have used sodium right here, so that's why we need to use dry ether. Why dry ether? Why not any other thing? Dry ether acts as a solvent medium for the reaction to take place because dry ether is a non-polar solvent. Do not want any kind of solvent which reacts or which interferes with the reaction. Okay, suppose instead of dry ether you would have taken water. फिर क्या होता? Water is really polar, right? So it was eventually gonna interfere, and suppose you put sodium inside water, the explosion would have had happened. So we just want a medium in which sodium also remains stabilized. Now what is the preference of alkyl halide which we are using right here? Alkyl halides in this reaction, primary and secondary do well. Okay, primary and secondary do well. If you are going to use tertiary, then it's gonna create problem in Wurtz reaction because it will eventually lead to the formation of alkene. Just before that I would like to mention one thing, like just here you have taken alkyl halide now, so two more reactions you are gonna see in this chapter which are same, literally the same, only the reactant difference is there a little. Like there would be a reaction which would be Fittig reaction. So in Fittig reaction, instead of taking alkyl halide they would be taking aryl halide. Okay, so similarly there would be a reaction which would be Wurtz Fittig reaction. So there are similarities between these three reactions. If you are very much clear with this, then you are eventually gonna go good with them also. So let us look into the mechanism. So there are two kind of possible explanations for the mechanism of this reaction. First one is free radical mechanism and another one is the anion mechanism. Okay, so here I'll tell you one thing. If you have ever studied chemistry on my channel, I always give the mechanism in simple steps. Okay, so here if we talk about the mechanism, step number one, which is single electron transfer, which is SET, and radical formation. So you know sodium is there, so two atoms of sodium are there, right? So metallic sodium, it gets dissociated into its respective cation, okay, Na plus, and it releases two electrons. Okay, this it releases inside the dry ether, which is the solvent. Okay, now there is alkyl halide also. One molecule of alkyl halide, see there is polarity between the alkyl group and the halide group always, you know na, that the halide group, it pulls the electron density towards itself, so there is a slight negative charge over it, and hence here a slight here is a slight positive charge. So electron would attack the electron which is being released inside the dry ether, it would attack, okay, on this slight positive, partial positive charge, and hence this will eventually get separated from it. So what will happen here, that these electrons, the electrons which are present in this bond, that this halide group, it will take along with itself, और ये अपना halide जो anion है वो बनाकर निकल लेगा. एंड यहाँ पर जो मीडियम में इलेक्ट्रॉन्स रिलीज थे उससे इवेंचुअली ये जो अल्काइल ग्रुप है इसमें पार्शियल पॉजिटिव चार्ज था, ये इलेक्ट्रॉन जो है वो इसमें अटैच हो जाएगा और यहाँ पर अल्काइल रैडिकल फॉर्मेशन हो जाएगा. सो सिंगल इलेक्ट्रॉन ट्रांसफ़र की हेल्प से यहाँ पर अल्काइल रैडिकल बन गया है आपके पास और यहाँ पे एक अनायन बन गया है. नाउ लेट मी एक्सप्लेन यू दिस स्टेप thoroughly, that what just happens over here. Now when we talk about this this alkyl radical, suppose this was the alkyl group, okay, methyl was there and it was connected to this, right? Now this bond is getting broken. Now there are 2 electrons in this bond, both of them are gonna be taken by this halide group and it is gonna separate out. Now what is left with this? It is having this, right, this alkyl group, and the electron which was there, it is gonna give this electron, the positive charge was here na, so this electron is gonna come here, it will give its electron to this positive charge. Now this will become a radical. Still this is not stable because it still needs one more electron to complete its pair. It's still like this, so it is in the search of one more electron. When it will get this electron, then only it's gonna get stable. Now that's why it is written as this radical. This still needs one more electron to get stabilized. Now this is highly reactive, this is highly unstable. So eventually if it gets one more thing like this only, so it will get combined with that na. Suppose one more radical it gets, now it will eventually get connected to that radical and hence it gets stabilized. So this is what happens in this reaction. Now see what happens over here is, again one more in step 2, again one more SET takes place and one more radical is being formed. Now eventually in step 3 dimerization happens. Dimerization means that both of them now combine and they now form a symmetrical alkane. And now why is it symmetrical? Because same alkyl halide was there. So if this is methane, this is also methane, so they are gonna get combined to methane it makes ethane now. So eventually it is gonna be symmetrical on either side. Okay, now what's left? Let us consider what's left. Now two sodium these cations were left and these two halide anions were left. Both of them are gonna combine. If it's sorry, I have written Cl over here. If it's Cl, then it's gonna be sodium chloride. Any other this can be there, halide, bromine can be there, iodine can be there, so any of them you can put. So there's one more mechanism to it, which is the anion mechanism. So what happens in this? Step 1 is the same, in which eventually the ions are gonna form. Okay, this here you saw the sodium ion, same like the other mechanism, this got formed, right? There is no partial charge which we are considering, directly the ion formation of the alkyl ion here forms and here the halide ion forms, right? And after that what happens? Carbon ion formation happens. Now sodium has released 2 electrons. Now these 2 electrons are gonna combine with this alkyl ion. Okay, now this will form carbon ion, right? Now 2 electrons, when they will combine to this, so eventually they are gonna form a carbon ion, right? Carbon ion will be formed. Now in step 3, SN2 nucleophilic attack will happen. Nucleophilic attack means nucleus loving species. Obviously this carbon ion is nucleus loving, so here eventually polarity will be there, right? Partial positive charge on this and partial negative on this. So it will see that it is eventually a nucleus loving species, so it will attack on it. Eventually it will break its bond with this and hence it will combine with this. So RR will be formed and this will be, now X negative will detach itself from there and it will be present inside the solvent, and eventually in the last step this sodium cation, it will combine with these anions and eventually a sodium salt will be formed. So that is well understood, that you can do yourself also, that formation, other product formation. The main requirement to understand is this only. Okay, So I hope you understood the topic well, and the next video will be regarding fatigue reaction. I'll be posting the shots of these reactions also. Please look into them also.